Hello guys, welcome back to Pathshala and today I am back with the part 5 of excretory system. Wow guys, this has been so amazing, right? And we have learned about the whole generation of urine process in such interesting steps. At one point looks like this is not even my body and then dramatically everything changes, right? We also broke down those complex names that we were never able to understand, these proximal convoluted tubule, distal convoluted tubule, and they actually seemed like real things, right? So those of you who are having FOMO and not understanding what I'm all talking about, the only answer you will get in the past four videos that we have worked upon together. So that you understand this better, I recommend you go a click, maybe watch them on twice the speed, and come back here so that you can understand what we are talking about today. Yes? So, today we are going to talk about the second structure after proximal convoluted tubule, the hairpin shaped structure. Remember, guys? Yes, the one that had a descending limb, the one that had an ascending limb. Yes, the loop of Henle. So in the past video, we had also talked about the glomerular filtrate, which literally filtered everything, and then came in proximal convoluted tubule that reabsorbed 70 to 80% things, also secreted some wasteful products. Then what is left for this loop of Henle? Well, we need to talk about it since it actually has the most important function. Guys, until now, nutrients, minerals were being talked about, but water still has not come into our conversation. So, actually, loop of Henle is that structure that maintains high osmolarity of your medullary interstitial fluid. Oh my god, ma'am, what are you saying? So, guys, let's understand it very easily. This you see in between your loop of Henle, and then in the red color we have the capillary, the vasa recta that runs parallelly. Under below these, this is the medulla where we have the interstitial fluid. The medulla, it says, has high osmolarity that needs to be maintained, which is being maintained by loop of Henle. Basically, this is what is meant. So, what is high osmolarity? High osmolarity means less water and high amount of solutes. Correct? Right? Whenever there are high amount of solutes, as soon as water passes near the higher osmolarity, the water is drawn. Right? It always moves from high to low. That is the basic principle of diffusion we have studied. So, the medullary interstitial fluid constantly needs to maintain a higher osmolarity so that it can reabsorb, it can drive the water back that has been filtered away by glomerulus. So, its maintenance is that important. Now I understand. So, now the question is, how is it this high osmolarity being maintained by loop of Henle? Well, there are two structures. First one is the descending limb, as you see. So, descending limb is permeable to water. It takes in as much as water as it can. So, your urine output that came from proximal convoluted tubule is only remaining with electrolytes. There are no electrolytes moving in, only water moves in. So, what happens? Your urine gets concentrated as it moves down, right? Now, as it moves up in the ascending limb, it is, on the other hand, exactly opposite, impermeable to water. But it is permeable to electrolytes by active transport, passive transport. So, as the fluid moves up, the fluid gets diluted. So, you see, there are opposite currents, right? And that generates an electric potential that leads to the filtration of your urine. Now I understand, ma'am. And this process, this opposite current, is basically called counter current. The goal of counter current is to produce a concentrated urine so that we don't end up wasting water. It's four times concentrated urine than your initial filtrate. And the components which are actually utilized in this generation of counter current are your Henle's loop and vasa recta. The counter current is basically the filter in Henle's limbs, like it goes like descending limb and then ascending limb as we talked about, and the vasa recta, which were the capillaries. If the fluid moves in like this, the blood in vasa recta will move like this. Yes, exactly opposite. When do things go opposite? They lead to the generation of current. Yes, the gradient. There is a gradient in between them. The difference between them, the osmolarity increases from 300 milliosmo per liter in the cortex of kidney to 1200 milliosmo per liter in urine, and that's how your urine gets concentrated. That's why this complex countercurrent mechanism that we are never able to understand is so important in our body, right? And it's so interesting, right, how a human body is formed. So, how does my body maintain this concentration gradient? There are different mechanisms. The few we need to talk about are sodium chloride transport. So, sodium and chlorine are transported by the ascending limb of loop of Henle's. As we also read about it again back, it is permeable to electrolytes but not to water, and it is exchanged with the descending limb. So there is ascending limb of loop of Henle, and here will come the descending loop of vas erecta. So they exchange it, right, and is returned to our interstitium, the medullary interstitial fluid. So there are more solutes electrolytes. So the high osmolarity of interstitial fluid of medulla is maintained. Also the urea transport. Urea enters the thin ascending limb of loop of Henle again. It is transported back to the interstitium by the collecting tubule that will come later in the picture. So the result is when this interstitial gradient is high, it pulls the water from the collecting duct, concentrating our urine. So that is why high osmolarity gradient is super important. So guys, I know this video was about the most difficult concept of biology, the concentration gradient, the opposite gradient, the counter current mechanism, and I know it must have felt like a relief factor to actually see it as an interesting concept rather than the most horrific thing to read about ever. And that is how biology. And if you are looking for such an interesting, complete study solution, you definitely need to check out Pathshala. They offer one-on-one live classes, instant doubt solving, and premium study materials that cover all grades and all boards. It's basically like having a personal tutor in your pocket. To get started, just download the app using the link in the description box. Search for the subject you want to learn, and they will connect you with the best teachers in the country. Seriously, go check it out. The link is right down below. And for such more interesting videos about human excretory system and other biological systems, please subscribe to this channel, like, share, and subscribe. And also, please comment down your queries so that we can help you out. And please keep studying and all the best. Take care.